So today for my final experiment, I'm performing a serial dilution, titrating ketones to determine the ketone quantity in a urine sample. And this experiment incorporates the idea of dilutions, acids, and titrations. I will be finding the amount of acetoic acid, which is also acetone, in a urine sample. And this will be done by performing a serial dilution of the sample with deionized water, checking acetone levels with ketone tablets, and observing the color change that will occur. The K-check or ketone tablets will change in color, which will indicate the concentration of acetone in the urine sample. The darker the color, the higher the concentration. We can apply our knowledge of acids to understand what it is that we are looking for in this experiment. We are testing for acetone levels, and we know that since acetone is an acid, that it will be donating a hydrogen ion to the base that it is combined with. We can make connections between titrations in this experiment because the K-check tablets work as an indicator by telling us how much of the sample is able to react, which also tells us the concentration because we can figure out how much ketone is present by how far the sample must be diluted in a series of serial dilutions. So I already labeled all of my test tubes and the tablets that we're using. I'm going to start by adding 200 nanoliters? Microliters, 200 microliters to each of our tubes. This is deionized water that I'm putting in. I think I go down one of them. Okay, so now we take 200 microliters of our urine sample and we put it in our first test tube. We're going to also take 1 drop of the urine sample and put it on our first ketone tablet as a control to show that we have what a positive would look like. We just do 1 drop. Okay, so we're letting that control sit for a second, and then I'm taking 200 microliters of that first test tube that has the urine and the diluted water. And we're taking 200 microliters of that and pipetting it into the next test tube to dilute it with the next amount of deionized water. You mix that, and then we're taking 200 microliters of that sample and placing it in the next test tube. We're continuing this process all the way through our test tubes. Now that they're all diluted, we will be removing 200 microliters from the last test tube just so that they all have the same amount of solution. Okay, so now that we have all of our test tubes diluted, we will be taking 1 drop of each solution and placing it on the corresponding tablet. So we're taking our 1:2 dilution, placing a drop of this on the 1:2 tablet. then for the 1 to 4, placing 1 drop onto the 1 to 4 tablet. And so on. Okay, now that all of the tablets have solution on it, we wait 2 minutes and then we will read them to see the concentration. So 2 minutes have passed, and that means that the reaction is complete. And we have this little paper that we can see whether, if it's yellow, that means that it's negative for ketones. And then we can see the small, moderate, and large amount, and that would be like 20 milligrams per deciliter. And so we can hold this up and we can tell that we have probably between a moderate or large amount of ketones in our original sample. And then as we dilute it, we see that the color slowly gets lighter and lighter until at the end, we can see that it's yellow. And because of that, we know that when somewhere between 1 to 64 and 1 to 28, the sample is diluted enough that we no longer are finding ketones in our sample. And that is how I do a serial dilution titrating ketones to determine ketone quantity in a urine sample. Thank you.